When we solve radical equations, we may not always be able to isolate the radical. So here in our example, I have the square root of 19 subtract k equal to 2 times the square root of k subtract 4. So on the right side of our equation, I have a 2 in front of my square root sign. So I would need to divide this over in order to isolate my square root. The issue is I don't have another number in front of the square root on the left side to divide 2 into, so I can't divide this number at all. So this is what we are left with. So we would have to then square both sides of our equation. Now when I square my left side, it is the way that we normally would eliminate our square root. So the exponent of 2 will take out the square root sign, and I would drop down my 19 subtract k. On the right side though, the exponent of 2 goes to the square root as well as to the 2. So I really have 2 squared and the square root of k subtract 4 squared. So I need to evaluate 2 squared to give me a 4. And then when I square my square root, the k subtract 4 will fall down. So I need to multiply the 4 into the k subtract 4. So I will have 19 subtract k equal to 4k subtract 16. Now I can finish the equation by solving for k. I'm going to add a k to both sides of my equation. So 19 will equal 5k subtract 16. I'm going to add 16 to both sides of my equation, and that's going to give me a 35 equal to 5k. I'm going to divide both sides by 5, and k is going to give me 7. So I too need to check this solution, so I am going to plug in 7 for k. So I get 19 subtract 7 in my first square root, which will simplify down to the square root of 12. The 2 will stay out front, and 7 subtract 4 is 3. If I simplify my square root of 12, I break it down into 4 and 3. 4 is 2 and 2. My pairs will go in front, so my square root of 12 is now 2 square roots of 3, and on the right side I have 2 square roots of 3 as well. So my solution checks.